Okay, now we are in lecture 5, and in this lecture we do the measures of central tendency. And in measure of central tendency we do mean, median and mode, because a value that represent a typical or central entry of a data set is known as measure of central tendency. Okay, and the most common measure of central tendency are mean, median and mode. So these three numbers represent the central value or central entry of a data set, and therefore these three terms are known as the central tendency or measures of central tendency. Okay, so we do mean, median and mode in this lecture. How to find the mean, median and mode. Mean. The mean is the sum of the data entries divided by the number of data entries. So we add the data values and then we divide by the total number of data values. And we represent mean with this symbol, x and a bar on top of it, equals to the sum of x divided by n. So we can also write it like this way. We can write mean, which is denoted by x bar, equals to the sum. This represents the sum. This symbol is the sum symbol, sum of x divided by n, where n is the total number of data values, and this is the sum. Okay, so we add all data values and then we divide by the total number of data values. Question 1. The price in dollars for a sample of round-trip flight from Chicago, Illinois to Cancun, Mexico are listed. What is the mean price of the flight? So we need to find the mean of these numbers, right? So mean x bar equals to, you add these numbers, okay? 872 plus 432 plus 397 plus 427 plus 388 plus 782 plus 397, and then you divide by, now you count how many we have. 1 2 3 4 5 6 7, so divide by 7. Okay, and this is equals to, now the sum of all these numbers divided by 7. You can do calculations, and I did the calculation, so I get 527.86. So what I did here is I first added these numbers and then I divided by 7, so I get this number. So this is the mean of these numbers. Okay, so this is the process of getting mean, is you always add the numbers and then divide by the total number of items. Okay, so this is how we find the mean. Okay, now we have another question. Find the mean of the given data set. So let me, alright, so we add these numbers and divide by the number of counts. Let's see, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 19. So we divide by 19. Okay, so you can add x bar equals to sum of all data values divided by n, right? Number of data values, number of data entries. Now you add these numbers. Okay, so you add these numbers. You could write like this, like adding all these numbers, like showing that I add these numbers, but I added these all in calculator and I get this sum is 3340 divided by 19. Okay, so I get 175.79. This is the mean. Okay, so finding mean is just like finding average. Average and mean are same. We add the numbers and we divide by total number of items. Okay, now question 3 is again find the mean. Find the mean number of hours Brandon is paid exercising per week. So we add these numbers. Okay, the sum of all data values, which is denoted by the sum of all x, is the sum of all x is here. You add all these numbers, you get 140.2, and then the mean, which is x bar, equals to the sum of all data values divided by total number of entries. So I get the sum of all data value 140.2 divided by, now there are how many numbers are there? 1 2 3 1 2 3 4 5 6 18. Okay, so n equals to 18, so we divide by 18, and this equals to you get 7.79. So that is the mean of this data set. Okay, now the next question is again the mean of these numbers. So we add again and then divide by the total number of items. Here it says homework, so let's erase this. Okay, so let's see, we add these numbers, add all data values, you get 58.8. so you add all these numbers, you get 58.8, and the number of entries n equals to, how many are there? 1 2 3 4 5 5 10 15 20, so n equals to 20. So the mean x bar equals to 58.8 divided by 20, and this equals to 2.94. This is the mean of these numbers. Okay, so that's how we find the mean. So to find the mean, you do what? You do add all numbers and then you divide by the total number of items. Okay, now let's go to the next topic, which is a median. So how to find the median? The median is the middle value of the observations when they are ordered from the smallest to the largest or from the largest to the smallest. So this is important. For the median, we need to put them in order. Okay, when they are order from smallest to largest or from largest to smallest. So for the mean, you don't need to put them in order because it doesn't matter, you have to get the sum anyway, right? But for the median, you have to do that. You have to first put them in order, and then you choose the middle value of the observation. So median is the middle position. You put them in order and then you choose the middle number, which number lies in the middle. Okay, how to determine the median? So first thing is you put the n observation in order for their size, order of their size. So you can put in ascending order or you can put in descending order, but you need to put them in order. And then if the number of observation n is odd, then the median is the middle observation. But if the number of observation n is even, then the median is the average of the two middle observations. So why is that? When you have odd number of data, then the middle number you get just one middle number. Sometimes you get one middle number if the data, the number of data values is odd. But if you have even number of data values, then you will get two numbers in the middle. Okay, so in that case, if you get two numbers in the middle, you have to find their average to get the median. So if you get one value in the middle, the middlemost value, if you get just one, then that is the median. But if you get two numbers in the middle, then you have to add them and then divide by 2. Okay, so that's how you find the median. Okay, so let's do these questions. So I pick one data set here and we find the median of the given data set. Okay, so we first put them in order. Okay, so let's put them in order. So when you put them in order, let's put in ascending order from increasing order. Okay, the smallest number here is I guess 388. Okay, so let's do 388 comma 397, another 397, 427, 432, and 782 and 872. Okay, so let's see, 782 and 872. Okay, so this is in order. So how many numbers we have? We have 1, 2, 3, 4, 5, 6, 7 numbers, right? So now we have 7 numbers. Now which number is in the middle? So you can choose it by your own way. Some people like to count all numbers and divide by 2 and then you add some technique, but you can just count it, like you have this in the first position and this in the last position, and then you count which number is in the middle. Okay, so 1 2 3 1 2 3, so this number here, right? So this number is in the middle. Okay, you got 3 number in this side, you got 3 number on this side, and so you have the 1 number in the middle, so that number is the median. So median equals to 427. That is the median. Okay, so but we need to put them in order, because if you choose the middle number without order, then it is possible that you end up with other numbers, right? So you always do the position and then you choose the middle number. You put them in order and then you choose the middle number. This question is, you have 1 2 3 4 5 6 numbers only, so you will get 2 numbers in the middle. Okay, so we put them in order. So when you put them in order, so we can put in ascending order or descending order. Let's put it again in the same way like we did here. The smallest one is 388, comma 397, 427, 782, 872. Right? Now which number are in the middle? So you see, you count it like 1 2 3 and then 1 2 3, right? So you get these 2 numbers in the middle. Okay, so now here we got just 1, so that was the answer. But here we got 2. So what you do is, here the median equals to, you add them and divide by 2. 397 plus 427, and then you divide by 2. Okay, so we have these two, the sum of these two, 7 7 is 14. Okay, so let me see. Okay, so what I get is 400. You add them and then you divide by 2. Okay, 412. You get 412. I skip the calculation here. I believe that you can do this. You add them and then divide by 2. Okay, so you get 412. Okay, now this question here, it says the homework. This is not the homework. Okay, so let's do this question. Find the median of the given data set. So we need to put them in order. Okay, so let's put them in order and then we find the median. Okay, now putting this in order, it may take time a little bit. So the smallest number is 50, and then 70. So we put them in order: 50, 70, and then okay, so which one next is 130? Is this 130? No, 100, 100, 130, 140, 140, 150. So 140, 140, 150. So 140, 140, 150, 160, 180, 160, 180. We got another 180, right? We got another 180. Okay, and what else after that? 190. Okay, 190, and then 200, 200, right? And then 210, 210, 220, and then we got two numbers, 290 and 340. 290 and 340, right? 340. Okay, so we got the numbers in order. Now let's choose the middle number. Okay, so which number is in the middle? So this is the first, this is the last, right? So go one step there, two steps there, and then these, these, and this. Okay, so I get this number. So let's count, maybe if it is odd or even. I got 180. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 numbers. Okay, so 19 numbers. So it has to be a single number in the middle because it is an odd number of count, right? Another way to get that position is you get 19 number. I'm just doing it here, but you can count it just like I did before, and you can choose the middle number. But if you have n equals to 19, then you can always do this. You can do n plus 1 divide 2. Okay, n plus 1 divide 2 is 20 divide 2, which is 20 divide 2, which is 10th position. Okay, you can do this way as well. 10th position. So now you count 10th position. 1 2 3 4 5 6 7 8 9 10. So you get this number as the middle number. So that is the median of the given data set. You can count it this way, that you can step by step, like you do the first and the last one, and then you go one step and there, and then 2 step, and then 3 step, and then 4 step, and then 5 step, and then 6, right? And then 7, and then 8, and then you ended up with the same number in the middle. So you could do that way. But sometimes when your data values, when your data entries, there are many number of data, then this is the best way to count. Okay, so you just do, if you count the total number and there are 19 numbers, you add them and then divide by 2, that gives you the number, and you just count that position. So I get 10th position, so that is the median. Okay, so this is the answer, 180. This is the answer. Okay, so we got the mean and median in this page. So let's go to the next page now. Okay, so here is outlier. So what is called outlier? Outlier is any observation or any data entry that falls well above or well below the overall bulk of the data. See, all the data numbers, all the data values are in this place, right? Starting at 30 and ending at 70, but one data is 100. So it looks like this is above. I mean, this is much bigger than the other set of data values. Okay, which look different from the other data values. So that number is called outlier. For example, like you say, all students in a class, if they're getting 20, 25, 20, 26, 25, all are getting the grades from 20 to 30. Okay, and there is one student who get 100, like, okay, let's say 95. Then see, all students in the classroom, all students in the class are getting grades from 20 to 30, right? So all are like getting 20% or to 30%. But there is one student who got 90%. Then that student is called outlier. Outlier is a person or a data or any item that looks not completely different, which looks like different from other person or other data entries, other data values. In the same way, like everybody is getting 90s, all are getting A's, and one student getting 15%. that 15% is outlier. Outlier is not only the bigger number, it can be the smaller number too. For example, like I have a data set. Let's say I have a data set where all data entries are 800, 850, 900 to 990, like that. And there I have one number which is 25. Then all data entries, all other data are above 800, and there is one data which is 25. Then that 25 is outlier. Okay, so any observation that falls well above or well below the overall bulk of data is called outlier. And the mean is greatly affected by outliers. Mean is affected by outliers because if there was no outliers, then we didn't have to add these numbers, right? So we only could add these numbers and divide by the total number. But because there is an outlier, there is a possibility that the mean is either increased or decreased by that single value. Okay, so if all are getting 20, 25, 20, 25, and one student getting 95, and when I get the average, when I get the mean of all students, then because of that 95, I get bigger mean, right? So the mean is greatly affected by outliers. And the median and mode are not affected by outliers because the median is the position-wise middle value, so that doesn't change, or that doesn't have much difference. But the mean will be changed because of the outlier. The mean will be affected mostly. So the mean is greatly affected by outliers. Okay, so that was just the concept of outlier. And let's go to the next topic, the mode. Mode is the value that occurs most often. In the histogram or bar graph, the mode has highest bar, right? So any value that occurs maximum number of times is called the mode. Okay, so find mode of the given data set. Let's see which number counts maximum number of times, and that number is called the mode. So here 5 count twice, 6 counts 3, and 8. So 8 counts 4 times. Okay, so 10 counts twice. So here you can write like this: 8 has the maximum frequency or count. So mode equals to 8. Okay, so which counts maximum number of times? That is called the mode. Okay, at a political debate, a sample of audience members were asked to name the political party to which they belong. Their responses are shown in the table. What is the mode of the responses? Okay, so what is the mode? So which data has the highest number of frequency? So we have 56 Republican. Okay, right? So the mode is Republican. Because that has the maximum number of counts, or maximum number of votes, or maximum number of frequency. Okay, now find the mean, median, and mode of the sample ages of the classroom shown this sample. Which measure of central tendency best describes a typical entry of the data set? Are there any outliers? Are there any outliers? Let's see if there are any outliers. Are there any outliers? See, all the data are 20, 20, 20, 20, 21, 21, 21, 22, 23, 23, 24. And there is one number which is much bigger than the other numbers, right? So that is the outliers. So yes, the outlier is 65. Now we find the mean, median, and mode. So let's find the mean. Mean is the sum of all numbers. Okay. Sum of all data values divided by number of data values. The sum of all data value, you add these all numbers and you get 475 divided by how many are there? 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 19, 20. Okay. And that is 23.75. This is the mean. Median is middle value in the sorted data, in the order data. It is already in order, right? So 20, 21 and everything in order. So there are 20 items. So let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And these two. So these two numbers are in the middle, right? Okay, so the median is 21 plus 22 divided by 2, which is 21.5. 21.5 is the median. And the mode is highest repeated number. 22 counts 3, 20 counts 5 times. So mode is 20. Okay, so that's how we find mean, median, and mode. Now there is one more question here. Which measure of central tendency is the best measure of central tendency for this question? Okay, among the mean, median, and mode, which one is the best to count as a central value for this question? Okay, see, the mode is 20, which is the first entry of data set. So that doesn't look nice, right? So because when we are talking about the central value, that doesn't look nice. So mode is not like that. It is a central value, but compared to 3, mode for this question doesn't look nice central value. Okay, now mean is affected by outlier, and because there is an outlier, mean also have some like weaknesses for this question. So the median is the best measure for this typical data. Okay, so for this data, median is the best observation. Median is the best observation to consider as the best measure of central value. Okay, so not mean because there is a outlier, not mode because mode is the first few entries. So the median represents the best observation to count the central value. Okay, now that was mean, median, and mode. And here I put few things just to give you some concept, like when we draw the graph of any data set, like these are numbers, so we can get the histogram like this. And when you get the histograms like this, based on the shape of histogram, we can compare the mean, median, and mode. So first of all, what types of sets we get, what types of diagram we get. The shape we get is like this, is perfectly like you have the same thing on both sides. If you get this type of set, if you get this type of diagram, then this is called the symmetric graph, symmetric diagram. Okay, symmetric curve. See, you have right, you have this shape, and this is the middle number here. So see, the same thing you look on this side, you'll get the same thing on that side, right? So so this type of shape is called symmetric shape of the data. And in this one, you look like the shape look like you have a long, this has a long tail on the left side. See, so it looks like it is deviated a little bit. It is not exactly the symmetric. It looks like it has a tail on this side. Okay, the long tail on this side. So this is called skewed left. If you have a long tail on left, it is skewed left, and it is skewed right. See, now you have a long tail on this side. Okay, so this is called skewed right. So these types of shapes we can get for any data. When we collect the data and draw the graph, the histogram or bar graph or something like this, we get these types of shapes. Sometimes we get a perfect symmetric shape. Sometimes we get a long tail on the left, so skewed left or skewed right. If it is a symmetric data, then the mean, median, and mode are same value, same central value. Okay, so this value is the mean, median, and mode. If you have a left skewed, if you have a long, like this graph has a long tail on the left side, then we get the mean first. Somewhere here we get the mean, and then we get the median, and then we get the mode. So the median comes first, and then the mean comes first, and then the median, and then mode. If it is a right skewed, then the mean is on the right side. Okay, so mean is always towards the tail, towards the tail. So we get the mean here, mean, and then we get the median, and then we get the mode. Okay, so depending on the shape of the data set, we can compare that if mean is larger, or the median is larger, or the mode is larger number. If it is a symmetric number, mean, median, mode are the same number. If it is skewed left data, then mean is a smaller number, and then the median number, and then the mode number, because the number which is on the left is the smaller number, and then larger, and then the larger. So you get the smallest mean, and then mean, median, and then mode. If it is skewed right, then you get the smallest number will be mode, and then the median, and then the mean. like this data. See this data which we had here. The smallest number was the mode, right? So mode was the smallest number, and then median, and then mean, and then mean is 23.75, median 21.5, and mode is 20. So this data. If you draw the graph, you'll get a right skewed graph. Why? Because see, if you draw this way, you can get this type of shape. And in this shape, mode is the smallest number, and then median, and then mean, which is like this one. Okay, so that was just comparing mean, median, and mode based on their graph. So this lecture was about the mean, median, and mode that we did it here. In the next lecture, we will have some other item, like how to find the mean of group data, how to find the mean of weighted mean, and some other stuff we'll do in the next lecture. Okay, so I'll stop here. So we did mean, median, mode, and I'll see you in the next video. Okay, thank you.